All right, so calculating limits. This was from limits at infinity. The first two examples are similar to what we did in class, and then the third one would have been from the small, what was it, an 11-minute video of, that I said I was going to finish, of vertical asymptotes, right? So what do I need to do when I plug in infinity with direct substitution? I get an indeterminate form, infinity over infinity. So how am I going to handle this one? One over x to the largest exponent. So in this case, that is going to be x to the fourth over 1 over x to the fourth. So I have to multiply by a form of positive 1. So what this is going to get me is the limit as x approaches infinity of 5 minus 3 over x squared plus 5 over x to the fourth. And then I have 2 minus 7 over x. And then when I take that limit, all of those numbers over a variable to a power go to 0. And if we were not showing our work, we were thinking about the fact that the numerator and the denominator would be approaching infinity at the same rate, basically, because infinity to the fourth over infinity to the fourth. So if that is the situation, the degree of the numerator is equal to the degree of the denominator, we know the limit is just going to be the leading coefficients. But if we have to show our work, this is the work that supports that. If it's a multiple choice question, you can just go with that. What about 2? I have to multiply by a form of 1, right? I have to multiply a square root by a square root and a non-square root by a non-square root. These are the same degree-ish, numerator and denominator. So I need to multiply by 1 over x squared, and in the denominator I need to multiply by 1 over x because the square root of 1 over x squared. But this one has an issue. I have to multiply by a positive 1. I am currently multiplying by a negative 1 because we are approaching negative infinity. My numerator is going to be positive. My denominator is now negative. How do I make this a positive 1? I make either the numerator negative or the denominator negative, correct? So then what I've got is the limit as x approaches negative infinity. In the numerator, I have the negative of the square root of 5 minus 12 over x, all under the square root. And in the denominator, I have 3 minus 7 over x. And now when I substitute in, I get the negative square root of 5 plus 0 over 3 minus 0. All right. There's going to be one like that one on the test. Don't forget that you need multiplying by a form of positive 1. So if when you plug in the value, you end up with a negative 1, you have to fix that to make it a positive 1. Okay? What about the last one? Can I factor the denominator? Which actually will make this problem a whole lot easier. Now, when I plug in a number slightly larger than positive 1, what do I get in the numerator? And when I plug in a number slightly larger than 1 and then subtract 1 and then square it, what's that going to give me? Negative divided by a positive is going to be a negative. A number divided by almost 0 is going to get me an infinity. Any questions on that? If I said I had a function, if this was my function, what is the 5/2? If this were a function, if I said f of x equals 5x to the 4th minus 3x squared plus 5 all over 2x to the 4th minus 7x cubed, what is represented by the 5/2? Horizontal asymptote, and the equation of that horizontal asymptote would be y equals 5/2. Here, this would be the y equals negative 5/3 if this was my function, would be the horizontal asymptote as x decreases without bound. Is it necessarily going to approach the same number as x increases without bound? Probably not. I'd be willing to bet it's probably going to approach positive root 5 over 3 as x increases without bound. And then what does this represent? If this were my function, what is the limit as x approaches 1 from the right represent? Vertical asymptote. If I take a limit at a value and I get an infinity, even from one side or from the other, I have a he already went. He already headed there. I'm not really sure what to do at the moment. And I'm still recording, aren't I? Okay, wonderful.